Give me a second. So language models have evolved into powerful tools endowed with large capacity to recall an unprecedented amount of human knowledge. As autoregressive models, they also possess the ability to take a user input text, a prompt, and perform a continuation of the text with causal generation of subsequent tokens, one at a time, in a manner that often results in detailed execution of the implied task in the prompt. Does that make sense, guys? For example, the input text may be a question, in which case the output text generated as a continuation is likely to be an answer to the question. Well, of course, there's still model hallucination, so you don't always get the right answer. I'll skip over the rest of this, but this is a beginning of prompting. We'll look at the old faithful guys. If you want to know the history of this data set, you can read it. But here is what I entered as the first prompt. And observe how I go about it. I first give it a role. I say, you are an expert data scientist with a reputation for methodical and careful exploratory data analysis. Why would I do that? So here is a mental picture that you should hold in mind. LLMs, they are like 1,000 PhDs behind a curtain. And you can't just ask it to do something. You just have to sort of invoke the right expert to step forward and do your task. Are we together? It has to, just like actors. See, a director doesn't just hire an actor and says, hey, why don't you start acting? Instead, you say, what role are you going to play in the movie? So LLMs are actors. The first thing you do is you give it a role. Right? The moment you say you are an expert data scientist, right, with a reputation for methodical and careful exploratory data analysis, it will go like, oh, wow, good. You do this by carefully studying the data, reasoning about it carefully, and step by step, and performing each of the tasks in that order. So you're giving it a set of goals, isn't it? I might even have broken it down into goals, but for what it is worth, I didn't. First goal you give it is, do an exploratory data analysis by first performing univariate and multivariate statistics on the data. Those of you who have taken my ML100, 200 courses, remember that I say, the moment you touch the data, the first thing you do is univariate and bivariate analysis. From this, you derive well-reasoned observations and findings. 2, then do a data visualization, both at the univariate and multivariate level. Then visualize as then do a data visualization both at univariate and multivariate level. These visualizations are aesthetically excellent, intuitive, and most importantly, surface the story the data is trying to tell. Style: formal, scientific, precise, and meant for a publication. Right? So you express in what language to respond. Tone: careful, methodical, and explanatory. Audience: who is it for? Your report is targeted towards scientists and engineers, i.e., with professionals from the STEM field. Response format: important. The response should be in-depth and at least 3,500 tokens, which at the time was aspirational. Actually, I should have just said 1,000 tokens, but there we go. Guardrails. And this is important. Guardrails tell what it should and should not do. So first thing you say, and notice that, do not use any external analytical plugin. Be sure that everything you say is grounded in the facts of the data. Do not make things up simply because it is plausible sounding. Right? So remember, LLMs are plausibility engines. If they don't know, they'll just make up something that you will believe. Right? So then comes, so this is the system prompt, and then the user prompt, objective. What is the goal? Right? So guys, if you think about it this way, I gave it a role, I gave it a goal, I'm giving it a goal, and I'm giving it a backstory and guardrails and style and audience. In the attached file, there is data in a tab-separated data format for the old faithful geyser, its eruption times and the time lag to the next eruption. Perform a detailed exploratory data analysis and aesthetically pleasing data visualization. So do you notice that, guys, that is my prompt looking like a one-liner? No, it never should. Never should. The first rule of prompting is it should never be, really, I mean, unless you really want something just short, it should be very carefully thought out. That's why I say that the way a poet writes poetry, write your prompts carefully. So what is the response? Look at the response. Let us now see the response that came from the language. And observe the level of detail that the language model can produce, as well as areas that leave for further improvement. For example, it talks about performing a regression analysis of the data in the multivariate analysis, but misses providing the details of that aspect. Right? So some wins, some losses. If you do it today, I think the results would be better. I did it long ago, 1 year ago. So univariate stats, most of you got this, right? The average duration, multivariate stats, the following following the stats, we will visualize the data to help communicate these findings more intuitively. So what do you notice? It has come up with a plan. You notice that when you are careful, it first tells you that this is the plan of how to proceed. By the way, this is core to the evolution of prompting into AI agents, which are the hottest topic of research these days. One of the hottest topics. So it will say it will do histograms, scatter plots, and box plots. So let's begin with the statistical analysis. And what do you see it's doing? Those of you who are familiar with pandas in Python would immediately recognize this code. It writes the code, executes it. Right? So it gives you even the code. And right away, what do you see? It gives you your mean, standard deviation, everything, and it gives you the correlation. 90% correlation. Are we together, guys? Right? Then it goes on to univariate analysis. So what it promised to do, it's doing it now. There we go. It has come up with all of this. Isn't it, guys? It has done it for you. It has found all of the univariate statistics. By the way, I'm not doing anything. It is the response to a single prompt. Much longer. Then it does multivariate analysis, correlation. Then it decides that it's time to do data visualization. Right? And it writes the data visualization code. Remember, what did we tell it? Your visualizations better look beautiful. Right? And sure, how many of you would look at this and say, you know what, it would have taken me quite some time to produce this? Do you like this? Okay. So it creates this visualization. Then it gives an explanation for all of this. This is something, it's so hard to make data scientists and engineers do. They'll quickly write the Python code. They'll show you the results. Then you ask, okay, what's the interpretation? They'll say, well, isn't it obvious? Hey, they don't want to write English. So here it is. Everything is explained to you in great detail. By the way, this is still the response to the first prompt, right? It goes on. It gives you a conclusion. And oh, there's somewhere in there a second prompt. Did I give a second prompt? No. No, it's the first prompt still. I don't know why I gave the topic the third prompt. It's actually the second prompt. Then I said, okay, I just said, create a kernel density estimator plot of the data and include the contour lines. Do you see that this is a very specific data science exercise? Most people don't realize that the LLMs are really very competent data scientists. How many of you knew that, by the way? That it could do things like that, that it could write code. You knew that. Very good. See, how did you know that? Were you using it for that? Yeah. Turn on this. If you don't mind, just turn this on. No, turn on the button, please. Yeah. And now, if you could repeat it, please.
So I'm a statistics major, and a lot of the models that we use for like regressive are like regression, linear regression, all that Like we definitely use like the LLM models to like help expedite the process.
Nice. And you knew that LLMs can do all this.
Yeah, yeah.
So this is it. And so guys, look at this. This code from here to here, there was a time when you gave it to an engineer and the engineer said, okay, how about I take this sprint to do it? Right. And a smart engineer would say, okay, maybe by end of the day. Right. So here we go. Right. And it just continues on. This was actually the second prompt, not the third one. By incorporating it, it speaks about it. Third prompt. Now perform the following task on the data and provide a response in no less than blah, blah, blah tokens. Perform a clustering of the dataset into optimal number of clusters. Understand each cluster and give it a descriptive name. And this is important. This is really thinking like a scientist. Give an understanding. What do the like typical thing people will say, okay, here is cluster data. You say, what does it mean? It means cluster 1, cluster 2. Right. But now you're saying no, give a physical intuition to it. Explain the details. Explain in detail the differentiating characteristic of each cluster and give it an interpretation. And here, see what it does. Clustering methodology. It will do the clustering, determine the optimal number of clusters. It will use the elbow method and silhouette method. Because in k-means clustering, you don't know how many clusters there are. This, by the way, impressed me because most of the time when I ask people to cluster, they'll ask me how many clusters. I say, well, figure it out. They'll use the elbow method. Rarely, and I have led data science teams for many, many years now, rarely would you find them use multiple measures. The point is clustering, all the measures, metrics are imperfect. So the only way you know that you got the right number of clusters, especially if you're using k-means, is if you use multiple metrics. So the nice thing is that it used two different metrics, the silhouette method and the elbow method. Do you see it here? It wrote the code, it did that, and then it is now using the elbow method. It is telling you, and the silhouette score, it is saying based on these analysis, two clusters appear to be the optimal choice for this data set, as this number provides a good balance within cluster variance and separation between clusters. And now it does the clustering and then it comes up with this. So obviously there are two clusters, red and blue clusters, right? Cluster analysis. And I ask it to name the cluster. So here's the interesting part. Here's the part that people find difficult. Look at the way it says k-means clustering has partitioned the blah data into two distinct clusters as visualized in the scatter plot. Each cluster represents a group of eruptions characterized by similar durations and waiting time. Let's delve into the characteristics and interpretation of these clusters. Cluster 0, short eruptions and shorter waiting time. So it's given name, short eruption, short wait time cluster. Mean eruption duration is this, blah. This cluster represents eruptions that are shorter in duration and followed by shorter waiting times. These eruptions are quicker and recur more frequently compared to the eruptions in the other cluster. Right? Cluster 2, long eruptions and long waiting time. Right? Approximately blah minutes, blah. This cluster comprises naming and interpreting cluster. So this is describing the cluster. Now it goes into the interpretational aspect of it. It says, it calls the first cluster the quick cycle. Would you agree with that in view of that? And the second one, it calls the long cycles. Not bad, right? And it says that the defining characteristic of the cluster is its relative short eruptions and durations and blah, blah, blah. These eruptions may be indicative of less energy accumulation within the geyser's plumbing system, resulting in blah, blah, blah. Right? Interpretation. And then it goes into the interpretation of it. Pretty good interpretation. Seasonal, etc. Because you told it the word reservoir, geyser. Because its knowledge knows what geysers are, it is now delving into its geophysical knowledge, right? Geothermal knowledge of it. And conclusion. And it goes further and further. See, guys, do you see a qualitative difference between naive prompting and careful prompting? Right? I hope I'm able to convey that. Next is the fourth prompt. Now your role is that of an expert geologist and geophysicist. So I'm changing the hat now, right? And I'm saying provide a detailed interpretation of the finding in no less than 2000 tokens and give additional domain specific context. So now what does it do? Look at this. It goes into the full theory of all of that interpretation and significance at all. Then after that, while I'm at it, I said, okay, now become an artist. Finally create an evocative picture of size blah, blah, blah by this many pixels, depicting the spirit of the findings about the old faithful geyser. How many of you would consider this to be fairly good art? So guys, I'll pause here. What is the lesson? What is the takeaway? What did you learn from that? Anyone would like to articulate? Does that guy deserve 350K for prompting? Right? Yeah. Because it takes patience it's like tennis or it's like poetry. You don't become poet overnight or become a great tennis player. What is that guy? I'm not into any sports. So I don't know. But I heard the word Nadal. Is that correct? Is that a big tennis player? Nadal. So you can't become Nadal overnight, isn't it? So it may not be deep programming, but it is certainly careful practice and thinking. And it takes time and effort to become that. Sanjay.
Are they hiring prompt engineers to test the LLMs, or are the
most startups these days are nothing but prompts? I mean, I wouldn't say nothing but because that looks derogatory. Let us just say prompt engineering today is at the core of most of the new startups coming up. Yes, what we have realized. So now once you see, at this moment, I'm peeling the onion layer by layer. When we go into the mathematics of it, when you dissect the large language models and look at how it is thinking inside, we just barely understand it. But what little parts we understand is a deep research topic. And when you see how deeply the LLM internally is reasoning, it is thinking like a world-class mathematician. Very deep reasoning it's doing. And all you're doing is you're invoking those very high cognitive abilities from the LLM. People ask, right, when will machines achieve super intelligence? Right. When will they take away a job? What's the answer to that? In many, many areas, they already exceed human intelligence, right? And oh, by the way, they're already doing your jobs. Right? That's the thing.
So once the output of the prompt is generated, like in this case,
yeah,
right, who's going to validate whether everything is correct?
That's something you will learn. That's that is how the introspective ability, self-refinement, self-critique. So prompting is a big topic. See, I'm teaching a whole course on prompting, 2-month course. And even then, I'm just barely scratching the surface. How did I become good at it? Like you, there's no shortcut to it. It is practice, 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 practice. Endless practice and reading research papers right now in a bit. Yeah, go ahead. That is exactly what I'll teach you right after lunch. Go ahead.
So one general question is, are they focusing on subject matter experts on different fields like finance, geology, biology? Are they the guys who are getting hired as prompt engineers?
Not necessarily. Believe it or not, the qualities that makes for good prompt engineers are empathy, clarity of communication, right? And believe it or not, people who are very good with role playing, right? They do extremely well. And for reasons that are dead obvious, engineers are actually pretty terrible at it. Yes, it is. It is domain specific. Yeah, Girish, you're absolutely right. See, what happens is that in no subject can you skip the domain, the subject matter expert. You take subject matter expert and a person who very good with articulating. And by the way, these things, right? What I'm talking is not mystery. I'm not asking you to write sonnets like Shakespeare. Those techniques, by end of today, you should be well on your way. In other words, the quality of your response will be far, far better. I remember in a previous batch, a person went through this exercise, went back and literally uploaded a crucial piece of data that was bugging those people for months, for 6 months, and they couldn't identify what was wrong, what the real bug was. Now they're not looking at code; they're looking at the outputs. And guess what? He wrote the technique that I'm going to teach you in the afternoon. He used that technique, and he couldn't believe it. He said that it immediately solved the problem and suggested 5 valid ways to fix it. Right? Simply by looking at the data, not even looking at the code.
My credit card.
Yeah, go ahead, Madhu.
Yeah, 2 comments real quick. I shared a quick link, a podcast that came in yesterday. 3 top prompt engineers from Anthropic. Excellent podcast, 1.5 hours. They explain, how they have learned prompting and why prompting is so critical and so on and so forth. Just as an informational. The second thing, as if I'm picking up some chatter about this reflection, which is a new model, that open source model that came out, and everybody's like super excited about it. Apparently the person that started this company is not a data scientist, so he was
Leave
curious
AI.
about
Leave
LLMs,
AI.
and he kept going back and forth and started learning prompting. Apparently he built this whole model with prompting. So I just wanted to mention that
Yes,
the power
yes,
of
yes.
prompting.
Madhu, thank you for bringing that up. You literally took the words out of my head. That would be my closing statement, actually. I was going to do that. Thank you, really, for saying that. So,
I'm
guys,
sorry.
no, it is excellent that you brought it. It just shows that it's really nice to see how clued in you are with everything. It's just awesome. In fact, even the news that this was, I think you alerted me or somebody alerted me 2 days ago when the model came out. Just a few minutes later, somebody alerted me. I think you did that, Mandeep. Mandeep, you did that. So this is a reflect here, what is it? Reflection. Yeah. All it does is it uses a prompting technique. So at this moment, the state-of-the-art models that have been released in the open source are Llama, right? And its competitors, Quen, and so forth. Llama and Quen are at the frontiers of it in the open source community. And then there are the commercial frontier models, the GPTs, GPT-4os and the clouds and the Geminis of the world, right? So what these guys have done is they took one particular form of prompting, reflection, self-reflection, right? And they created tons of training data with that. And then they essentially trained or tuned the model. They took a Llama, the leading Llama model, Llama 70 billion parameter model. So see, guys, the frontier models are big. The Llama 405 billion model is huge, the biggest open source model. Right? I believe Grok released by XAI is even bigger or something to that effect. But Llama 405B, can we use it for practical purposes? The fact that it is open source is it's almost like, you look at the moon and you say how beautiful it is, but you can't go there, right? You and I don't have the budget to go there on our Sunday vacation, right? So it's like that. Then the reasonably accessible model was the Llama 70B, 70 billion parameter model, which also barely, like for example, we are running 70B in the data center. You guys all have access to it, by the way, right? At least 2 teams I know have access to it, right? And so what these guys did is they just trained the data using a prompting technique. And as Madhu, thank you for bringing this, because this is the heart of it. Guess what that model is doing? At a tiny, minuscule 70B, it put up a David and Goliath fight with the frontier models, and it beats them all in most benchmarks. Can you think about it? Actually, there is a link. Mother, would you mind, if you happen to have the link handy, would you
I
mind
did.
please posting the link on
I
Hugging
did.
Face? You did.
I
Okay,
just
thank
did.
you.
I just did.
Okay.
Another chatter going on about that, as if they built this model so fast, like 2 days or 3 days. I'm trying to validate that fact, but I will share that when I validate that fact.
That's right, because it should be just fine tuning it, right? With this new instruction, with the new data set. They took a Llama 70B and fine tuned it. So in any case,
Asif, can Madhu post it in Discord as well? Because
yeah. I think he posted it in Discord.
Discord, okay.
General
general,
discussions. So guys, this is it. The power of prompting. Can you imagine? It takes $124 million to train a frontier model. That's what it costs to train Llama 3.1, 405 billion parameter. Right? How much money it takes to train GPT-4o or cloud or something is not known. But the word on the street is it's somewhere in the order of billions. And here comes a tiny startup that uses a technique borrowed from prompting to train this model, take the 70 billion parameter Llama and train it further. And it beats basically every frontier model in most benchmarks. If anything should tell you that prompting matters, I hope this does. And instruction fine-tuning matters. Like with reflection is a form of instruction fine-tuning. Instruction fine-tuning with reflection. You create data in which you have all of that. But that's the power of it, guys. Right? So if you haven't used that model, those of you who have a 4090, go quickly download it, because there is somebody told me, who was it? Praveen mentioned that it might not stay open source for long. Download it before it disappears.
And
Actually, sorry, go ahead.
And the 405 billion reflection model is coming out. 405 actually is coming out next week.
Next week. Wow.
Yeah.
This would be a moment, right? For the first time, an open source model will completely open weights model will completely beat all the commercial frontier models. It's quite a movement. It took 1.5 years since GPT came out, ChatGPT came out, for this moment to happen. So guys, this is it. So here I will end with the points to ponder. For this simple data set, was a careful prompting even necessary? And the answer is yes, right? How much did we gain from using a methodical approach? Discuss it with other participants today. So guys, think about it, talk about it, and see how does it compare with the Jupyter notebooks you would have created? Those of you who have data science experience and have been creating this, would you agree that this result is at least at par, if not better than what most people would have created in Jupyter notebooks? Right? And for example, how would you compare it with the sample solutions for Intro to AI course on the same problem? By the way, this is, I'll leave you, those of you who are doing the Intro to AI, they have seen the Jupyter notebook for the Old Faithful Geyser, right? The analysis that I did. You can go compare it. You'll find the relevant notebooks on our course portal. Discuss the pros and cons between the analysis done by the language model and that from our Jupyter notebook. What are the strengths and gaps of each? So for example, guys, do you notice that it started out by saying I have to do regression, but forgot to do it? So how would you improve the prompts to make sure that it does the regression analysis? Right? So the prompts that I've given you are starter prompts. You can improve upon it. What would have happened if we had tried to apply clustering methods by prompting the language models? Would it, for example, have done a good job with DenClue, DBScan, or agglomerative clustering? Try it out on your own. Apply the CoStar framework. So this is the framework I'll teach you in the afternoon. What happens if you repeat this exercise with other commercial language models such as Cloud, Gemini, etc.? Right? Experiment with it and discuss the findings with other participants in the cohort. Did you have to make material changes in your cohort? What did you learn from this? Likewise, repeat this experiment with some of the available open source models. So try this with Llama and other things. What do we need to do to your prompt if you use some of the smaller 7 billion parameter models? So how much does it work if you use a smaller model? Hint, hint. If you use a smaller model, what should you do? Break down the task into smaller tasks. It will do it. Yeah. And how does the result differ from using a bigger open source model? So these are things that you should try it out. Please do try it out and play with it. I hope this was food for thought. I started this prompting with a general motivation, and I hope I've motivated you to learn prompting well. Prompting is a big topic. Today, I'll keep you here or much later in the day because I would like to cover at least the core prompting techniques, right? So for that, you'll be here. But I suppose it's time for lunch, and I'll stop the recording. It is 1 o'clock. Should we guys take half an hour? How long do you want?